This video is about putting the general form for conics, which you see at the top of your paper here, into standard form so that you can graph them, because standard form tells us information about the characteristics of the graph. To do this, we do a process called completing the square. So just to give you a brief overview of completing the square is adding something to an x squared and an x term, or any variable squared and a variable term, so that I can factor it into two identical binomials. And identical is the key here. So for example, in the first one, I know that the first two terms have to be x. Now to get 10 for the middle term, I have to have half of it in each binomial. So I divide that in half and say that's 5x. So that means I have to put a 5 in the second term of each binomial, making them both plus. And then if I were to multiply this out, the third term would be 5 times 5, which is 25. So that's called completing the square. The goal is that I can then write this as x plus 5 squared. And you'll notice that in all of these, there is a quantity squared. And that's why we need to be able to do this, is to write that quantity squared in each of these standard form equations. The next one, x squared plus 5x plus blank. I do the same thing with the x's, but then 5 doesn't divide in half as easily. So, but it's not that bad. Half of 5 is either 2.5 or 5 halves. I recommend for the fraction. I think it's easier to do the completing the square with the fractions visually, but you can do either one. If I made this 5 halves, then notice what I would add would be 25 fourths. And then I would end up with x plus 5 halves squared. You could also end up with x, you could also make this 6.25, and this would be 2.5, and 2.5 squared is 6.25. So that would be another way to do it with decimals. The third one is a little different because we don't start out with an x squared, and you can't do the completing the square unless the first term is just a variable squared without a coefficient. So if you see a coefficient, the first step is to factor out the coefficient. And you have to factor it out of both of these terms. So dividing 3x by 3 gives me x squared. Dividing 4x by 3 gives me 4/3 squared. I'm sorry, 4/3 x. And now I need to complete the square inside. So actually I shouldn't have drawn the blank at first, because I can't complete the square with the 3 there. I have to factor out the 3. Then I complete the square inside the parentheses. So once again, I need to write this as a binomial squared. So I have an x and an x. What is half of 4/3? Half of 4/3 is 2/3. You can just say 1/2 times 4/3 that way, and you can see that would be 4/6 or 2/3. So I'm going to put 2/3 here and 2/3 here. And then 2/3 times 2/3 is 4/9. So I end up with 3 times the quantity x plus 2/3 squared. Okay, now let's apply this to an equation of one of our conic sections. So we're going to start out with this equation here. And hopefully you remember from the previous video that if we have two squared terms with different signs, that it is a hyperbola. So you always want to start out by identifying the figure and then writing down the equation that you're trying to get to. So you're trying to get to something like this: x minus h squared over a squared minus y minus k squared over b squared equals 1. So my goal is to end up with an equation that looks like that at the end. Now it could be that the y will be the positive one and the x will be the negative one. I'm not sure when I start solving which one it's going to end up to be, but it's going to look something like that. So first step is to group together the x's and y's, because we have to do those separately. So I'm going to group together 2x squared plus 12x, and then minus 3y squared minus 12y, and then I'm going to add the constant to the other side. So I add 6 to the other side. Then I'm going to factor out, because I have coefficients here, I'm going to factor out a 2 from the x terms, and I'm going to factor out a negative 3 from the y terms. So it's actually maybe better to write this as plus negative 3 minus 12y to help you remember that. So starting out, we'll factor out a 2 out of the, oops, I want to stay in red here, a 2, and then this would be x squared plus 6x plus blank and then plus negative, oops, I don't want a parenthesis here, sorry, plus negative 3 times y squared, and then be careful here, I'm factoring a negative 3 out of the negative 12y, so it'd be plus 4y plus blank equals, and then I'm going to have 6 plus blank plus blank. Since I'm adding two things on the left, I have to add two things on the right. So completing the square, I'm going to have 2 times, and I'm going to put my two parentheses here. I'm going to have an x and an x. Half of 6 is 3, so I'm going to add 3 to each of the x's, and then my last term is going to be 3 times 3, which is 9. For the other one, it's going to be plus a negative 3, and then factor into two parentheses. I'll have a y and a y. Half of 4 is 2, so I'm going to add 2 to each of the binomials, and 2 times 2 is 4, so I'm adding 4. Now we always have to do the same thing to the other side. So what am I adding to the other side? Am I adding 9 and 4? No, 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 not 9 and 4. Because notice the 9 is inside a parenthesis with a 2 on the outside, and the 4 is inside a parentheses with a negative 3 on the outside. So what I'm really adding is 2 times 9 and negative 3 times 4. So I'm going to write this up here, 2 times 9, negative 3 times 4. So this is 18, and this is negative 12. So what I end up with here is 24 minus 12 is 12. So writing this a little more simply, it's 2 times x plus 3 squared minus 3 times y plus 2 squared equals 12. Well, this is looking very promising. Going back to look at our equation that we're headed towards, we just need the right-hand side to be 1. So I'm going to divide everything through by 12, which gives me 2 times x plus 3 squared over 12 minus 3 times y plus 2 squared over 12 equals 1. Am I done? No, because as long as there are coefficients in the numerator, I'm not yet in standard form. I need to do something about this. There's 3 ways we can do this, 3 ways of looking at this. It all gives the same result. If it's a fraction that can be reduced so that there is a 1 in the numerator, you just reduce the fraction. So 2 twelfths is 1 over 6. 3 twelfths is 1 over 4. That's a really simple thing to do in this case. However, sometimes there is not an easily reduced fraction. So what you really have to think about is a couple of things. Notice that what I'm doing to get the 1 over 6 is I'm taking the 12, dividing it by the 2, and putting the 6 in the denominator. 12 divided by the 3 puts a 4 in the denominator. Another way I could look at it is I'm multiplying both the numerator and the denominator by the reciprocal of the numerator. So I could say 1/2 times 2 and 1/2 times 12. 1/3 times 3, 1/3 times 12. So for a simple one like this, reduce the fraction, but you're going to see some messy ones later where multiplying by the fraction is going to be a good strategy. So this just becomes x plus 3 squared over 6 minus y plus 2 squared over 4 equals 1. And that's my final answer. It's in standard form. Now you may be wondering, this is a little more complicated looking hyperbola than what I saw before. It's got this 3 and 2 in here, and we didn't have that before. We just had x squared over something and y squared over something. So what does that additional number do? What that additional number does, the numbers do, is to shift the hyperbola off the origin. So the center is no longer at the origin. The center has been shifted. So think about when we did before, when we added something inside the parentheses for x, it did the opposite of what we expected. And here when we add something inside the parentheses for y, it's also going to do the opposite. So basically we're looking for the number that makes the parentheses equal to 0. So for x it would be -3, for y it would be -2. That's our new center. Center HK is equal to -3, -2. Now we can look and see our A is equal to plus or minus the square root of 6, which is plus or minus, and I've got that calculated 2.4. And B is equal to plus or minus the square root of 4, which is plus or minus 2. So what we're going to do is plug plot the center point first. So we have negative 3, negative 2. From the center, we'll count 2.4 to the right and to the left. So that gives me a little point here, 1, 2, a little point here. Then we're going to count up and down 2. So one's right on the origin here, or right on the x-axis, I'm sorry, and then down 2. This will create the little box. So I'm going to draw the box just kind of in red here because it's not actually part of the hyperbola. It's just a framework for the hyperbola. Then I'm going to draw in my asymptotes, which cut diagonally through the box. And then there's just two more things. Which direction does it open and where are the foci? So which direction does it open? Well, the x term is the positive term, so it's going to open in the x direction. So I will draw my vertices on the middle side of the box in the x direction, and then draw it so it goes along the asymptotes. Remember that a hyperbola is basically straight except for right at the vertex. So you're not going to see, it's not going to do like this, okay? Don't draw a hyperbola so it looks like two parabolas back to back. Now the foci are calculated by doing c squared as the square root of a squared plus b squared, which would be the square root of 10 in this case, and that is 3.2. So I count 3.2 from the center, and this is going to be very close to the vertex, kind of hard to see on this grid. I should have made a bigger grid. 1, 2, 3.2, so probably about right here. 1, 2, 3.2, kind of right here. So they're very close. It's kind of hard to tell because I think I drew my parabola not exactly on, or my hyperbola not exactly on the vertex. Now the next problem, I want you to try yourself. If you think you can do this and try yourself, whoops, I don't want you to see it yet. I want you to try yourself and try to draw it and graph it. So stop the video and try to do it, and then turn the video back on and check your answer. And if at any point you get stuck, go ahead and turn the video back on. Okay, we're back on here with the ellipse. The correct answer is in the box. X squared, x minus 2 squared over 16 plus y minus 5 squared over 9 equals 1. And here's the correct graph. If you got that, then feel free to move on to the next problem. Fast forward a little bit. If you did not, I'm just going to give you a few tips. First of all, you should recognize this as an ellipse because of the two positive squared terms, and write down the equation of the ellipse. That's what you're trying to aim for. It's the same as what we did before, only no negative sign anywhere in it. Then you need to factor out the 9 from the x squared terms. I'll actually group the x squareds, y squareds, make sure to subtract, so it's negative 292 on the right hand side. Factor out a 9, so you should have x squared minus 4x. Factor out a 16, so you should have y squared minus 10y. Now we haven't done anything where the middle term was negative, but realize if the middle term's negative, that just makes both numbers in the binomial negative, but when you multiply them together, a negative times a negative is a positive, so the third term is always going to be positive, so always make sure to do that. Another thing people forget sometimes is when adding to the other side, first of all, you have to add to the other side. Secondly, you're adding 9 times 4 and 16 times 25. Then when we combine the terms on the right-hand side, you should get 144. Dividing both sides by 144, you end up with 9 over 144. If I multiply 1/9 times 9 and 1/9 times 144, I end up with 1 over 16. 1/16 times 16 and 1/16 times 144, I end up with 1 over 9. That was kind of handy. The center is at positive 2, positive 5. We're going to go out plus or minus 4 in the x direction, plus or minus 3 in the y direction, and the foci are at the square root of 16 minus 9, which is the square root of 7, and that's 2.6 in either direction. Now the last problem is a messy equation. In other words, the two we've gotten before have turned out with really nice numbers. Everything's nice integer numbers, everything divides evenly, but I'm not always going to give you a problem where everything divides evenly. So you need to know how to have confidence to do the same procedure when the numbers are not nice. So we are going to attack this problem. Notice first of all there is no x term. That's fine. I just have a 5x squared. Secondly, the 3y squared plus 2y, those are already grouped nicely for me, and I'm just going to add 1 to the other side. Now I could think of the 5x squared, well, I'll skip that for a second, just leave it alone because there's really nothing to factor out there. Factor out a 3, and I'm going to have y squared plus, well, if I divide 3 by 3, I get 1. If I divide 2 by 3, I get 2/3. Y plus blank equals 1 plus blank. I'm only adding one thing, so I only need one blank. Then I need to figure out what half of 2/3 is. And let me just stop here. I could think of this as 5 times x minus 0 squared if I want to, or I can just leave it as 5x squared. So whatever your preference is. If I factor this into two binomials, I get a y. Half of 2/3 is 1/3, and then plus 1/3 each time. And then 1/3 times 1/3 is 1/9. But be careful, I'm not adding 1/9 to both sides. I'm adding 3 times 1/9, which is 3/9 or 1/3. So this turns out to be 4/3. Don't put it as 1 and 1/3. In algebra, always use the improper fraction. Also, don't put it in decimal form because it's not an exact decimal, so you will just create error in your answer when you do that. Same thing with the 1/3. Okay, so this can be 5 times x minus 0 squared plus 3 times y plus 1/3 squared equals 4/3. Now you could divide everything through by 4/3, or you could multiply everything through by 3/4, which is what I recommend. Whenever you're dealing with fractions, it's better to multiply by the reciprocal than to try to divide by the fraction, because that just makes more of a mess. So when I multiply everything through by the reciprocal on both sides, remember that's both of these terms, I would get 15 x minus 0 squared over 4 plus 3 times y plus 1/3 squared over 4 equals 1. Now I'm almost there, and I forgot to at the beginning mention that this is an ellipse because these are both positive terms, so we are looking for the general equation for an ellipse. I don't want the 15 and the 3 in the numerator, and here's a case where I can't reduce the fraction nicely. So this is where that little multiplying by a fraction trick comes in handy. You want to say 1/15 times 15 and 1/15 times 4, 1/3 times 3, and 1/3 times 4. Remember, I can multiply by 1/15 over 1/15 because that's just a funny form of 1. Let me scoot this up a little bit so you can see a little better. Now, 1/15 times 15 is 1, so this just leaves me with x minus 0 squared, or just x squared in the numerator, and that leaves me with 4/15 in the denominator. And then I have y plus 1/3 squared in the numerator of the second term, and 4/3 in the denominator equals 1. Once again, leave it as 4/15 and 4/3 because if you try to make a decimal approximation, it will just be an approximation. It will not be exact. This is the exact form. Normally, we don't like fractions in a fraction as a final answer, but in this case, to put it in standard form, it is a necessity, so you need to do that. I'm not going to ask you to graph that, but a squared would be 4/15, so if you wanted to graph this, a would be plus or minus the square root of 4/15. In that case, it would be appropriate then to use a fraction or a decimal answer. B would be, actually I think it'd be the other way around because I think 4/3 is the bigger number. So a would be plus or minus the square root of 4/3. The center would be 0, negative 1/3. So you could graph this. It would be a very small, baby tiny ellipse because the square root of 4/3 and the square root of 4/15 are very small numbers, and your focus would be the square root of 4/3 minus 4/15, also a small number. So you could graph this, but it would be a little messier to graph, so we're not going to graph this. Hope that helped.